Good morning, all of you. So, in the last class, I guess now we were discussing about the SF6 circuit breaker. Let us continue. Also, let us continue with that. Let us continue with the previous topic. So, as you know, single pressure puffer type SF6 circuit breakers are more common, are one of the most commonly used circuit breakers. So, basically, see this is the diagram of the single pressure puffer type circuit breaker, where the components are already marked over here. Now, this figure shows the fully closed. By the way, did I cover this in the previous class, students? Did I cover it? Did I cover this topic in the previous class? No, okay. So the figure illustrates the fully closed position of the interrupter. Okay. The moving cylinder is coupled with the movable conductor against a fixed piston, and there is relative movement between 1 and 5. Now, what is component number 1? Let us locate that this is component number 1, movable cylinder, and 5 is this. See, this is 1, a movable cylinder, and 5 is this is a fixed piston. And so as you can see this movable cylinder, there's an arrow mark shown over here, means what, this cylinder can move in this particular direction, and this is a fixed piston over here. So there is the moving cylinder one is coupled with the movable conductor two. That is, this is, so you can see, means what, this is the movable conductor cylinder. It is coupled with this movable conductor two over here. These two are coupled to each other, and this is a arrow mark, and you can see one arrow mark shown over here. So together, this entire assembly can move in this direction. So moving cylinder is coupled with the movable conductor against a fixed piston, and there is a relative movement between 1 and 5. That is a moving cylinder and the fixed piston, and the gas is compressed in the cavity 6. So where is located? Locate the cavity. So this is the cavity. Just visualize, if this is fixed over, if this is fixed over here, and this entire assembly, this one, it is moving in like this direction. Just to what happens, the gas is getting compressed inside the cavity over here. So what happens, the trapped gas is released through the nozzle 4. So where is nozzle? No, this is the nozzle over here. So means what happened, once this cylinder is moving over here like this direction, like this, and gap comes over here. So trapped gas is released with the through the nozzle number 4 during the arc extinction process. So during the travel of the moving contact, that is 2, so you can see this is the moving contact over here, and this contact, you can see this is a fixed contact. The fixed contact is fixed over here, and the moving contact moves. Okay. So again, what you can see, this trapped gas is released through the nozzle during the arc extension process. During the travel of the moving contact and the movable cylinder, the gas puffs over the arc and reduces the arc diameter by axial convection. Means during the travel of moving contact movable cylinder, the gas is means when the moving contact traveling, and means along with the moving cylinder, the gas is puffing over the arc, okay, and reduces the arc diameter by axial convection and radial dissipation. So what happens at current zero? So I told you in AC wave, when the current becomes zero, the arc diameter becomes too small and the arc gets extinguished. The puffing action continues for some time even after the arc extinction and the contact space is filled with the cool fresh gas. Okay, means the puffing action will continue someday even if the after arc extinction contacts will filled with the cool fresh gas. Figure 7.7a, that is, I'll tell you, yeah, this one. This is the actual figure over here. The figure illustrates a configuration of 245 kV slash 420 or 420 kV single pressure puffer SF6 circuit breaker. The two interrupters They are mounted on the hollow support insulators. So let us locate now where the interrupt and hollow support insulator. So component number two, or component number three, where is two is interrupter. So means what this one? So means what this one and this one. These two devices are the interrupter, and component number three. This one is the hollow support insulators. Okay. The principle of the arc interruption is illustrated in figure 7.6. Means already I've told you what's the principle of arc extinction. The operating mechanism one means, as you can see, this is the operating mechanism over here. Okay, so this is the operating mechanism. So operating mechanism one is installed at the base of the insulator. Okay. One more thing, students, you need not learn this complex diagram. You can just try to visualize in short. For example, this is the operating mechanism, this is the hollow support insulator, and these are the interrupter units. The operating mechanism one is installed at the base of the insulator, is linked with the movable contact. Means what, this you can see a box like structure. This is the operating mechanism. It is installed at the base of the insulator, is linked with the movable contact in the interrupter. I mean, this is linked with the movable contact interrupter by means of insulating operating rod. Number four, if number four is insulating, let us look at number four. You can see a rod like structure over here. This rod like structure, this is the insulating operating rod over here. Okay, with the help of this insulating operating rod, this operating mechanism is connected to the moving contact with the help of this rod over here and a link mechanism. So where is link mechanism? That is component number five. You can see this one. This is the link mechanism over here. So as you can see, these are the interrupter units you can see over here. The circuit breaker is filled with SF6 gas at a pressure of 5 kilofarad per centimeter square during the opening operation. Now, what happens means when the means what, when the contacts of the circuit breaker have to be opened, the operating rod, that is component number four, is pulled downwards by the operating mechanism. मीन्स क्या होता है जब भी आपको ओपन करना है टू कॉन्टैक्ट दैट टाइम these two contacts, this operating rod is pulled downwards, you can see, by the opening mechanism, and the linkage mechanism, that is component number 5, it converts a vertical motion into horizontal motion. Means what, when this is going downwards means what, a pressure is coming over here like this, so this will get again pulled towards the right hand side. So what is happening, thus the two contacts will get opened. It converts, that's it, will convert vertical to horizontal motion, and the contact and the movable cylinder in the interrupter are moved against the fixed piston, the way I told earlier over here. The same principle is being followed. Okay, the contour linkage mechanism converts the vertical into, means when this is pulled downward, this will also go towards this side. That's what happening. The contact movable cylinder, they are moved they are moved against the fixed piston. The brake time up to 3 cycles can be achieved by the puffer principle described above. For achieving 2 cycle brake time, differential member, means with the help of puffer principle, brake time up to 3 cycles can be achieved. Okay, for achieving a 2 cycle brake time, a differential piston is used in which the puffer cylinder and the piston move in the opposite direction, thus reducing the total stroke and the time of the travel. Okay, this was about the single pressure puffer type SF6 circuit breakers. Now you need not study this one double pressure dead tank. It's now become obsolete totally. It means currently, as I told you, this single pressure puffer type is being commonly used nowadays. Let us study the next type of circuit breaker, that is vacuum circuit breaker. Yeah, this is the vacuum circuit breakers. Now again, the dielectric strength and the arc interrupting dielectric strength and the arc interrupting capability of the vacuum is superior to those of the porcelain, oil, air, and SF6 at atmospheric pressure. Means what is doing, it is comparing the arc interrupting capability of these materials. So dielectric strength and arc interrupting capability, the arc interrupting capability of the high vacuum is superior to that of the porcelain, oil, and air in SF6 at atmospheric pressure. SF6 at 7 atmospheric pressure and air. Okay, SF6 at 7 atmospheric pressure and air at 25 atmospheric pressure have dielectric strengths higher than that of the high vacuum. Okay. So I repeat, the dielectric strength and arc interruption capability of high vacuum is superior to porcelain, oil, and air, and SF6 atmospheric pressure. The SF6 at 7 atmospheric pressure and air at 25 atmospheric pressure have dielectric strength higher than that of the high vacuum. The pressure of 10 raised to power 5 minus 5 millimeter of mercury, okay, the pressure of 10 raised to power minus 5. Okay, but 10 is to minus 5 millimeter of mercury and below is considered to be a high vacuum, and low pressures are generally measured in terms of torr. So 1 torr is equal to 1 millimeter of mercury. So it has now become possible to achieve pressures as low as 10 raised to power minus 8 torr. Okay, so pressure of 10 raised to power minus 5 millimeter mercury and below is considered high vacuum, means it's telling that the SF at 7 atmospheric pressure and air at 21 pressure have direction higher than a high vacuum, correct? Again, so pressure of 10 raised to a minus 5 millimeter mercury and below is a high vacuum, okay, and low pressure generally measured in terms of torr, so 1 torr is equal to 1 millimeter of the mercury. It has now become possible to achieve pressures as low as 10 raised to power minus 8 torr. So 1 torr is 1 millimeter of mercury, means 1 millimeter of mercury. So you understood. So when I say high vacuum means 10 raised to a minus 5 millimeter of mercury and below. Now, student, let us see the working principle now. When the contacts are separated in a gas, just 1 minute, please. When the contacts are separated in a gas, the arc is formed due to ionized molecules of the gas. Okay, so I repeat, when the contacts are separated in a gas, the arc is formed due to ionized molecules of the gas. The mean free path of the gas molecule is small, and the ionization process multiplies the number of electrons to form an electron avalanche. Okay, so in a high vacuum of the order of 10 raised to a minus, as I told you, when I'm saying high vacuum means I told you again, the high vacuum means 10 raised to power minus 5 millimeter of a mercury. The mean free path of the residual gas molecules become very large. It is of the order of a few meters. Okay, therefore, when the contacts are separated by a few millimeter in high vacuum, an electron travels in the gap without collision. Okay, therefore, when the contacts separated by when the contacts are separated by a few millimeter in high vacuum, an electron travels in the gap without a collision. So, formation of arc in high vacuum is not possible due to formation of electron avalanche. Now, again, in vacuum, arc electrons and ions do not come from the medium in which the arc is drawn, but they come from the electrodes due to the evaporation of the surface material. Okay, due to evaporated surface material, the breakdown strength is independent of gas density. Therefore, it depends only on the gap length and the surface condition and the material of the electrode. The breakdown strength is highly polarized and thoroughly degreased. Now, when contacts are separated in a high vacuum, see what this was saying under when the contacts separating gas, that time we are telling. Whereas, see what happening when when the contacts are separated in high vacuum, an arc is drawn between them. Again, the arc does not takes place on the entire surface of the contacts, but it only on the few spots. Okay, and the contact surface is not perfectly smooth. It has certain micro projections. So at the time of contact separation, these projections form the last point of the separation, and current flows through these points of separation, resulting in formation of a few hot spots. So these hot spots emit electrons and act as a cathode spots. Okay. So in addition to thermal emission, the electron emission may be due to the field emission and secondary emission. Now, as you can see, students, as you can see this figure, you can see this figure over here. So as you can see, this is the figure of the vacuum circuit breaker over here. So figure this 14.2, that is this particular entire figure, this is the figure of the vacuum circuit breaker. Its enclosure means the outermost covering is made up of the insulating material such as glass, porcelain, or glass fiber reinforced plastic. The vapor condensing shield is made up of synthetic resin, and the shield is provided to prevent the metal vapor reaching the insulating envelope. So, as the interrupter has a sealed construction, a stainless metallic bellows is used to allow the movement of the lower contact. So one of its end is welded to the moving contacts, and its other end is welded to the lower end flange. So its contacts have a large disc shaped faces. Okay, so its contacts are having a large disc shaped faces. So these faces contain spiral segments so that the arc current produces the axial magnetic field. This geometry helps the arc to move over the contact surface. Okay, so I repeat, this geometry helps the arc to move over the contact surface. So movement of the arc over the contact surface minimizes the metal evaporation and hence the erosion of the contact due to arc. Two metal end flanges are provided. They support the fixed contact, outer insulating enclosure and vapor shield and the metallic blows. The sealing technique is similar to that which is used in the electronic valves. Now again, so this is basically the main construction of it is shown, and along with the working of this vacuum circuit breaker explained. The vacuum circuit breaker is very simple in construction compared to other types of circuit breaker. Again, the contact separation is about 1 centimeter, which is adequate for the current interruption in vacuum. Okay, so as the breaker is very compact, the power which is required to close and open its contacts is much less as compared to other types of breakers. Okay, so as the breaker is very compact, the power required to close and open its contact is much less as compared to other types of breaker. So it is capable of interrupting capacitive and small inductive currents without producing excessive transient over voltages. So the vacuum circuit breakers have other advantages like suitability for repeated operations, least maintenance, silent operation, long life, and high speed of okay, the suitable repeated operation, least maintenance, silent operation, long life, high speed of the dielectric recovery, less weight of moving parts. So these are main advantages that you understood means it is means this vacuum circuit breakers can be used in repeat operation. It requires least maintenance of this breaker, silent operation, long life, and high speed of the dielectric recovery. Even the moving parts are less weight. The vapor emission depends on the arc current. In AC, when the current decreases, the vapor emission also decreases. So near current zero, the rate of vapor emission tends to zero. Okay, so immediately after current zero, the remaining vapor condenses and dielectric strength increases rapidly. So at a current zero, the cathode spots extinguish within 10 raised to power minus 8 seconds. Okay, so the rate of dielectric recovery is many times higher than that obtained in other types of circuit breaker. Its typical its typical value may be as high as 20 kilo. A typical value may be as high as 20 kilovolt per microseconds. Okay. So again, the vacuum circuit breakers have now become popular for voltage ratings up to 36 kilovolt. So up to 36 kV, these breakers they employ a single interrupter. Okay, so vacuum circuit breakers have become very popular now for voltage ratings up to 36 kilovolt. So up to 36 kilovolt, they employ a single interrupter. Now let us go to next topic that is mechanical life and the electrical life of the circuit breakers. Before that, let me take your attendance. Yes, roll number 1 to 10. Please tell me your roll number one by one in ascending order.
Roll number 4.
Roll number 3.
1 minute, 1 minute. Roll number 3 and roll number.
4. Roll number 5.
Okay.
7.
Just 1 minute, 1 minute. Okay, roll number 4, 5, or 3, 4, 5, then roll number.
7.
Okay,
Roll number 10.
Sir, roll number 8.
okay, and roll number 10. Okay. Anybody else? Roll number 1 to 10. Then roll number 11 to 20.
13, 14, 14,
14, okay,
15.
okay. 11 to 20. Anybody else? Then 21 to 30.
Roll number 21.
Okay,
Roll number 25.
okay,
Roll number 26.
Okay.
Roll number 27.
Okay.
Roll number 29.
Okay.
Roll number 30.
Okay. 21 to 30. Anybody else who's remaining? Then 31 to 40.
36.
37.
36, 37. Okay.
40.
40. Okay. Anybody else? Roll number 31 to 40. Next, roll number 41 to 50.
42.
42. Okay.
44.
Okay.
45.
Okay.
49.
Okay. Forty-one to 50. Okay. Then 51 to 60.
So 52.
Okay.
56.
53.
56. Okay.
57. 53.
Okay. 56.
53.
53.
53.
Okay.
3.
Anybody else? 51 to 60.
60.
Okay. 61 to 70.
64.
64. Okay. Okay.
70.
Okay.
63.
63. Okay. Then 71 to 74. Anybody present from 71 to 74?
Sir, roll number 20.
Okay.
Sir, roll number 32.
20, 32. Okay, number 54. Mic problem. Okay.
Sir, 62.
62.
Sir, 20.
I marked all dinner. Why are you honestly repeating again? Okay.
72, sir.
Huh?
72.
Okay.
Sir, roll number 59.
You should be on time, students. Don't honest because I am having other work also in parallel.
Yes, sir. Sorry.
Yeah. Next topic, that is mechanical and the electrical life of the circuit breakers. See, mechanical and the electrical life of the circuit breaker. This I have taken on the internet. I have referred to the internet. I have referred. First, let us try to understand what do you mean by mechanical or the electrical life of the circuit breaker. Now, circuit breakers, whether it is air circuit breaker, vacuum circuit breaker, MCCB, etc., you must know about the number of mechanically and electrical operations or the life of that circuit breaker. Now, basically, see these parameters, that is mechanical and the electrical operation, when it's a life or means mechanical or the electrical operations of a circuit breaker are described by the manufacturer in its detailed technical specification. Now, for an electrical engineer, these are very important while designing their electrical system. First, mechanical operations or the mechanical life. As clearly from the name, mechanical operations of a circuit breaker is see, mechanical, when I say mechanical operations or mechanical life, okay? As it's clear, the mechanical operations of the circuit breaker means it's a number of times a circuit breaker is made on or off, okay? Now, electrical operations or electrical life. Now, electrical operations are basically, these are those operations in which the circuit breaker is made on or off or trip at the available power supply. Okay? I repeat, electrical operations or electrical life. So these are those operations in which the circuit breaker is made on or off or trip at the available power supply. Now, for a MCCB, the life of the MCCB is getting lower as the rating of the MCCB is getting decreased. Sorry, increased. Means as the rating is getting increased, the life is getting lower. Life means nothing but the operations. Mechanical, I told you, mechanical operations means the number of times circuit breaker has been on and off. Electrical operations means the operation in which circuit breaker has been on or off or trip at a available power supply. Now again, for example, let us take an example. Let us take an example for the MCCB's data is below. A rated current up to 100 amperes. The mechanical life is 8,500 operations. Means these many operations circuit breaker can perform on or off. Okay. The number of times we can make 8,000 and the electrical life is 1,500 operations. Means the operations in which the circuit breaker is made on off a trip at a power supply. Rated current from 100 ampere to maximum 315 ampere, the mechanical life is getting reduced to 7,000 operations and electrical is getting 1,000 operations. Similarly, when the rated current is increased from 315 ampere now to 630 ampere, the mechanical life is 4,000 operations and the electrical life is 1,000 operations. Similarly, as and when further the rated current is increased from 630 ampere by 800 ampere, mechanical life is 2,500 operations and electrical life is 500 operations. Now for air circuit breaker, the number of operations is follows. Rated current up to 1600 ampere, then mechanical is 20,000 operation, electrical is 5,000 operations. So as we increase the rate, see in case of air circuit breaker first, if the rated current is up to 1600 amperes, the mechanical life is to 20,000 operations, electrical is 5,000 operations, and the rated current from 1600 amperes to maximum 3,200 ampere, the mechanical life is 15,000 operations, and the electrical life is 5,000 operation, and rated current from 3,200 ampere to maximum 5,000 ampere, the mechanical life is 10,000 operations, electrical life is 2,000 operations. So is it clear? So we, as and when we increase the rating of the circuit breaker, the life of the circuit breaker is getting decreased. And in this Word document, I have already shared with you all in the Google Classroom. So you can access it directly from there. Let us read the next topic, that is testing of the circuit breaker. See, even in SSO chapter 15, it's mentioned over here, the rated mechanical life. See, chapter number in SSO chapter number 15, they have mentioned the rated mechanical life of a switching device is expressed in terms of number of switching operations can be performed without loading the current path. Okay. So I repeat, the rated mechanical life of the circuit switching device expressed in terms of number of switching operations can be performed without loading the current path. Now again, the nominal value of the rated mechanical life is assigned as 90% of the limiting value. Means number of operations which can be performed without loading the current path is the mechanical life. So most of the circuit breaker switching devices, they're capable of performing more than the assigned number of switching operations during the life. Okay, again, these are few more term contact life and also this is not mentioned, it's not required as per syllabus is concerned. So this is not required. Contact life means like the LV switching device is designed and rated to perform large number of mechanical operations per hour and several thousand mechanical operations during its operating life. That's called contact life. Means these terms are complementary. Mean those switching devices which are rated for low voltage. The LV switching devices, it is designed and it's rated to perform large number of mechanical operations in 1 hour and several thousands of operations during its operating life. This is all about the mechanical. Let us go next to the testing of the circuit breakers. Testing of the circuit breaker. The classic now again the test on the high voltage. Let us see the what are the different types of tests which is performed. Okay. So basically the test on high voltage, the test on the high voltage AC circuit breakers can be classified as follows. First, a development test. So basically, these are carried out on components, sub-assembly and complete circuit breaker during and after the development of the circuit breaker. Okay, so I repeat development test. So these are the components, sub-assembly, and complete circuit breaker during and after the development of the circuit breaker. So again, the designers and the research scientists verify the effect of various parameters on the behavior of circuit breaker by conducting the development test. There's in industries what happens when the circuit breakers come manufactured and before putting in service, some testing is done on the circuit breaker. Development test means on a component, sub-assembly, and complete circuit breaker during in the development and after development of this are carried out. Means what they do basically, the designers and the research scientists, they verify the effect of various parameters on the behavior of this circuit breaker. Means what is the effect of this voltage, suppose current on the behavior of circuit breaker, that has been verified by the designers by conducting development test. Now, development tests are not specified in standards. Next is type test. Now, basically, these are conducted on the first few prototype circuit breakers of each type to prove the capabilities and to confirm the rated characteristics of the circuit breaker of that design. Okay, means the type tests are conducted based on first few prototype circuit breakers of each type to prove the capability and to confirm the rated characteristics of the circuit breaker of the design. So type tests are not counted on every circuit breaker. Next is routine test. The routine tests are also performed as per the recommendations of the standards. The routine tests are conducted on the each circuit breaker. These are performed on the manufacturer's premises. The routine test confirm the proper functioning of the circuit breaker. Okay, so next is reliability test. Remember the type test and the routine test, they're conducted on new circuit breakers under laboratory condition. The performance of the circuit breakers installed at the site is affected by the additional stresses such as variation in ambient temperature, variation in dust, humidity, operation, maintenance schedule, etc. So basically, what's the main purpose of reliability test? The reliability tests are conducted to verify the reliability of the circuit breaker. Reliability means trustworthiness of the circuit breaker under various stresses occurring in the actual applications. Last one is commissioning test. The commissioning tests are conducted on the circuit breaker after installation at the site to verify the operation readiness and the proper functioning. So these are the different types of tests which are conducted on a circuit breaker. Need not study in that detail. So again, for this topic, refer chapter SS Rao, chapter number 10, one is 10.1. Note down for this topic, refer SS Rao, chapter 10, one 10.1 only. That's it. I told earlier, please give importance to previous year question was only. Because in syllabus, everything they have given from SS Rao. Next is HRC fuses. Okay. Now basically first, let us now try to understand what HRC fuses. Now again you have to refer SS Rao chapter number 14 you have to refer. Now again fuse is a simple current interrupting devices for protection from excessive currents. Or that you are already familiar with this term fuse. It's a simple protective current interrupting device for protection from excessive currents. As such, it is used as such, it is used for overload and or short circuit protection. Means it is means OH fuses are used for overload protection as well as for short circuit protection in medium voltages up to 33 kV and low voltage up to 400 volt installations. So modern high rupturing capacity cartridge fuses provide a reliable discrimination and accurate characteristics. Okay. So repeat modern high rupturing capacity cartridge fuses provide a reliable discrimination and accurate characteristics. So in some respects, HRC fuses are superior to the circuit breaker. Okay. Now again, let us go to types of the devices with the fuses. First, semi-enclosed or rewirable type. See, the fuse which we can see in our homes are generally of this type, that is semi-enclosed or rewirable type. The fuse carrier can be pulled out and blown out fuse element, that is a wire which melts, can be substituted by the new one. So I repeat, the fuse which are using house it semi-enclosed or it is semi-enclosed और rewireable type बोलते हैं जो घर पे जो हम लोग घर पे इस्तेमाल हम लोग करते हैं. Okay. No, basically the fuse carriers the fuse can be pulled out and can blown out and the blown out fuse element can be substituted by a new one and the carrier is replaced in the fuse base. Okay, that is called that is called the semi-enclosed or the rewirable type. To second one, that is totally enclosed or totally enclosed or cartridge type. The fuse element, that is when I say fuse element means the conductor which melts is enclosed in a the fuse element is enclosed in a totally enclosed container and is provided with the metal contacts on both the sides. Means the fuse element means the connector wire is enclosed in a totally enclosed container and it's provided with metal contacts on means the connector which melts is enclosed in a totally enclosed the fuse element is enclosed in a totally enclosed container, yeah, and is provided with the metal contacts on both the sides. This type is available in two types, that is D type and bolted type. Now third one, that is we have current limiting fuse links. A fuse link which is limiting the current to consider low value means a fuse link which limits the current to consider lower value than the prospective peak is called the current limiting fuse link. And fourth, dropout fuse, a fuse link in which the fuse carrier fuse carrier drop out after the operation of the the fuse link in which the fuse carrier drop out after the operation of fuse, they were providing isolation between the terminals. That is called dropout fuse. And fifth, what is expulsion fuse? A fuse in which the arc occurring during the operation of the fuse is extinguished by expulsion produced by the arc. Okay. Expulsion fuse is what? A fuse in which the arc occurring during a fuse in which the arc occurring during operation of the fuse is extinguished by expulsion produced by the arc. Six, one HRC, high rupturing capacity. So a cartridge fuse link having breaking capacity higher than the certain specified value above 16 kiloampere for modern voltage cartridge fuses. And seventh one, that is striker fuse, a device which incorporates a fuse and mechanical device. The operation of fuse, it releases striker with certain pressure and displacement. And eighth one, see, we are in switch fuse, that is a combined unit comprising fuse and a switch. Clear? So in order, we have 8 types: semi-enclosed or rewirable type, totally enclosed or cartridge type. Third, current limiting fuse link. Fourth, we have dropout fuse. Fifth, expulsion fuse. And sixth one, HRC. And seventh one, striker. And eighth one is switch fuse. Again, this topic is very important topic. It has been asked in the university question papers. Now, students, in your syllabus, everything they have mentioned, everything has been mentioned with respect to this HRC fuses. But students, in the previous year question papers, only one question has been repeatedly asked in so many years. You have to explain the construction, working, and advantages of the, I repeat, you have to explain the construction, working, and advantages of the HRC fuse. That is only asked. एक तो ये पूछा गया, explain different types of devices with the fuses. Also explain the construction, working, and the construction of working of the HRC and advantages. So first I'll focus on that and then I'll go to these remaining topics. So construction, working, these are different Badiram I will take. Yeah, Badiram refer chapter number 15. Now again, this HRC fuses, since I told you this question was asked for many years, this question has been asked, explain the construction, working, and the advantage of HRC fuses. I also explain different types of fuses has been asked, just state different that has been asked. The HRC fuses which are coping up with the increasing rupturing capacity on the distribution system, and it overcomes the severe disadvantages which are suffered by the semi-enclosed rewirable fuses. It's cope up with the increasing rupturing capacity on distribution system, and it overcomes the serious disadvantages suffered by the semi-enclosed rewirable fuse. So in an HRC fuse, the fuse element, which is surrounded by the inert arc quenching medium, is completely enclosed in the outer body of the ceramic material, having good mechanical strength. Okay, so I can show you for a student. This is a This is a diagram of the this is a diagram of HRC fuse. So in HRC fuse, a fuse element is surrounded by the inert arc quenching medium. So we can, inert means it's surrounded inert arc quenching medium. So you can see here over here. This is the inert arc quenching medium is over here, and completely enclosed in the outer body of ceramic material. Means the outer body is made of the ceramic material. We can see outer body of ceramic material over here, having good mechanical strength. The unit in which the fuse element is enclosed is called the fuse link. Means the unit in which the fuse link, the fuse link is replaced when it blows off. मीन्स जहाँ पे फ्यूज एलिमेंट एनक्लोज किया जाता है उसको बोलते हैं फ्यूज, दिस इज कॉल्ड द फ्यूज लिंक बोलते हैं. द फ्यूज लिंक इज रिप्लेस व्हेन इट blows off. In simplest form, an HRC fuse consists of a cylindrical body of ceramic material. That this is a ceramic material over here. You can see over here. This is a cylindrical body of ceramic material, usually steatite. Ceramic material means steatite or pure silver element. Pure silver, that is ceramic material, which is steatite. Um, Cylindrical body, pure silver or bimetallic element has for silver bimetallic element. Pure quartz powder. So you can see here there's a pure quartz powder, brass and caps. So these are, you can see these are the brass and caps over here. Okay. So these are the brass and caps over here, and the copper and these are the contact blades. So look at the, so we can see this element, and these two are the brass and caps, and these two elements are the copper contact blades over here. Okay, the fuse element is fitted inside the ceramic body. So this is the ceramic body over here. The fuse element. Okay, the fuse element is fitted inside the ceramic body. Yeah, and the space within the body surrounding the element is completely filled with the pure powdered quartz. You can see over here, the fuse element is fitted inside the ceramic body over here, and space within the body is filled with the pure powdered quartz. The ends of the fuse element are kind of metal and cap. That is, you can see these are two brass and caps over here. Okay, which are screwed to the ceramic body by means of a special forged screws. The end contacts, that is the end contacts, that is the contact blades over here, the copper contact blades, okay, are welded to the metal end caps. So these contact blades are bolted on the stationary contacts on the panel. Okay, so these contacts are bolted on the stationary contacts on the panel. Now again, the fuse element, that is this one. This is of as you can see in diagram. So this is the fuse element over here. The fuse element is either pure silver or bimetallic in nature. Normally, the fuse element has one or two sections which are joined together by means of a tin joint. Okay. The fuse element in the form of long cylindrical wire is not used. Okay, so I repeat, normally the fuse element has two or more sections which joined together, but means the fuse element means the fuse wire is either pure or silver or bimetallic in nature. Normally the fuse element has two or more sections joined together by means of a tin joint. So again, the fuse element in the form the fuse element in the form of a long cylindrical wire is not used. Because why? Because now the question is, why don't use long cylindrical wire? And that two means what the author is saying, that two sections are there joined to a tin joint. The fuse element is not used from a long cylindrical wire because after melting it will form a string of droplets will forms, An arc will be struck between each of the droplets. Because after melting, what will happen? It will form a string of droplets. An arc will be stuck between, yeah, arc is stuck between each of the droplets. Later on, these droplets will also evaporate and a long arc will be stuck. में droplets के बीच में भी arc हो जाएगा, then these droplets will evaporate and long arc will be stuck. The purpose of the tin joint is to prevent the formation of the long arc. That's why I told you the fuse element is having two or more sections which are joined together by means of a tin joint. The main purpose is to you are preventing the formation of long arc. So as the melting point of the tin is as the melting point of the tin is much lower than that of the silver, the tin will melt first under fault condition. Okay, so as the melting point of the tin is much lower than that of the sun, mean the tin melts at a lower temperature than the silver. And I told you why silver, because the fuse and silver are bimetallic. So tin will melt first under fault condition, and the melting of tin will prevent silver from attaining high temperature. The shape of the fuse element depends on the characteristic which is desired. So what happens, see, when the fuse carries a normal rated current, the heat energy is not sufficient to melt the fuse element. I repeat, when the fuse element carries normal rated current, the heat energy is not sufficient to melt the fuse element, but when a fault occurs, the fuse element melts before the fault current reaches its first peak. Means when the fault is occurring, the fuse elements melt before the fault gets the first peak. As the element melts, it vaporizes and disperses. During the arcing period, the chemical reaction takes place with the metal vapor and the quartz powder, which is forming a high resistance substance that helps in quenching the arc. Thus, the current is interrupted. Clear? So next class, I'll go through advantage and disadvantage. I'm going to go to next class. So stop over here. So next class we'll continue with this topic further. Okay. Thank you.